Hello guys, welcome to the competitive exam solutions. Fourth question. This is also a question which was taken from the NET December 2017 examination, and this is also from the part B. Okay, B part. So let's have a look at the question. So this is the question: a plain electromagnetic wave. Okay, from within a dielectric. So inside a dielectric, the wave is coming. Okay. So inside the dielectric there is epsilon, which is 4 epsilon 0, and mu is equal to mu 0, permittivity and permeability. So it comes out to the air. Okay, at some point z is equal to 0. Okay, so the magnetic field is given. Okay, don't get confused with this magnetic field and all that. So this is a common example of a distraction they done. Okay, so this doesn't require the magnetic field evaluation or anything like that. So I need to find out the angle of reflection and refraction. Okay, so let's have a look at it. So the situation is like this: you have a surface. Okay, this is the surface, a dielectric, and a wave is coming out of it. Okay, a wave is coming out of it at an angle. Okay, and on the surface, in the surface at z equal to 0, this is the point, and on the surface the wave is going to be transformed into a refracted wave and a reflected wave. Okay, two waves. So that's happening. So the angle of this is the angle of refraction, so you call it RF, and this is the angle of reflection. Okay, so this is theta reflection, this is the incident angle. Okay, this is some theta. So the basically, as you can see, the reflection and incident angle will be the same. So this will also be, so theta of r must be equal to the angle of incidence, the same. Okay, that's one thing. You don't need the magnetic field and all that to evaluate the condition. So one more thing that they have given is that inside this dielectric there is epsilon is equal to epsilon r. Inside that medium is 4 epsilon 0, 4 times the permittivity of free space, and mu is equal to some mu 0, the same. Okay, magnetic permeability is the same. Now what I can do is that I can just simply write down Snell's law. Okay, so Snell's law state that sine of the angle of reflection by sine of the angle of incidence must be equal to the refractive indices of the two things n1 by n2. Okay, that's Snell's law. Okay, where n must be equal to c by v, so n1 must be equal to c by v1, so n2 must be equal to c by v2, the relative speeds. So further you can say c v must be equal to, okay, let's wait. Okay, so that's it. So you can divide by n1 by n2, because we have n1 by n2 in this equation. So you can divide n1 by n2 and you get n1 by n2 will be c by v1 by c by v2, right? So you get v2 by v1, simple. So v will be, so c is generally written as 1 by the, for a medium, particular medium of permeability and permittivity. So c, the velocity in that medium, will be 1 by root of mu 0 epsilon 0. You know that. So now you can, what you can do is that you can put this into this equation, v1 v2 by v1. So you get, for particular case it will be mu r and by epsilon 0, right? So the second medium is the air, right? Second medium is the air. The first medium will be the inside and the second medium will be the air, outside, right? So it's coming out of a dielectric to the outside world. So now the v2 will be the air, so you can write down that it will be 1 by what, 1 by mu 0 epsilon 0 square root of that divided by 1 by square root of mu r, which is the first medium, epsilon r. Okay, so straightforward, you can substitute that value of mu r. So mu r must be equal to what, mu r is equal to, given, it is given, so the mu r is value is given, so mu r is just mu 0 and epsilon r is just 4 mu epsilon 0. So substitute that back into this equation, and you get 1 by this thing, right? 1 by mu 0 epsilon 0, the square root of that, divided by root of mu 0, mu r is just mu 0 and epsilon r is just 4 epsilon 0. So you simplify that, okay, simplify that, and you get 1 by square root of what this is 1 by as well, right? So 1 by 1 by 1, so that will be what, 2, 1 by, so that will be 2, right? So it will be 1 by 1 by 2, so that will be equal to 2. So that's what you get. So you got that v1 by v2 by v1 is equal to 2. So let's substitute that back into this equation. N1 by N2 is just v2 by v1, so substitute here. So sine of theta r by sine of, okay, sine of theta I is just what is it, 2. Okay, so sine of reflection, I'm going to write down r, theta r is just r, must be equal to 2 times sine of incidence, right? So in our option, let's get back to the, so in our options, as you can see, there are 45, 30, 90 and 60, right? 4 angles. So these are different combinations of 1 between 0 and 1, okay, and they are root 3 by 2's, 1 by 2 for sine of those will be root 3 by 2, 1 by 2 and all that, right? 1 by root 2. So which one is satisfying? So the only possible solution for this to cancel each other, so this must be this value and this value must be equal to some, there must be some cancellation, so this must be equal to 1, because all the other thing possibilities of root 3 by 2's and 1 by root 2 won't cancel with the 2 here, okay. So the 2 here will ensure that it won't cancel, so 1 must be equal to 2 times 1 by 2 could be the possible solution. So sine r will be sine of r will be 1, and sine of incidence must be equal to 1 by 2, or in other words, r refracted angle will be equal to what, 90 degrees, and incident angle will be equal to 30 degrees, right? So that's the correct option, that's the correct answer. So I hope you guys understood this question. Very simple question, very direct, but it is very useful. It's hard to miss these kind of questions, easy questions. So with that, I'm closing this problem session. Thank you guys, subscribe and watch. Okay.